Good day, I hope you are doing well. In this video, I plan to show you how to prepare your data for getting z-scores. Now, z-scores assume that the population data is normally distributed, so you want to make sure that your data is prepared before you convert it into z-scores. As always, make sure you open up the Excel spreadsheet in the directions below. I'll share my window so you can see exactly what we're doing as we walk through those directions step by step. Now, you always want to begin by taking a look at your data, getting used to your variables so that you know exactly what you're working with. Here it looks like we have several participants. We have a measure of what looks like to be satisfaction. It's on a 7-point scale, and also looks like a variable called alcohol. Now remember, you can always go down into your code book to see how those values in those variables were measured. So it looks like this satisfaction variable is a self-report survey that was asked of students on how satisfied they were with their current life situation. The other variable, alcohol, asked students about how much do they spend on alcohol in a week. Now these are real data from students in a previous semester, so whatever we find here is representative of at least students that we've had at Auburn University. Now I'm going to go back to the data sheet. And again, it's a good idea to kind of just scroll through and look at your data before you do anything. It looks like you have about 80 participants, a little bit short of 80 participants. And it looks like there's a couple of blank cells. We're going to have to deal with those later before we get our z-score, before we do our transforms as well. And so when we get to that point with this alcohol variable, we will move those blank cells down to the bottom, just like we talked about in previous lectures. So now that we've taken a look at the data, let's go ahead and look at our Excel directions. You're going to notice that there's two parts here. There's a part on preparing your data. That's step number 1. Step number 2 is actually getting the z-scores. So this video is going to focus on step number 1. The next video is going to focus on getting the z-scores. Now, before we can get z-scores, we want to do our best to make sure we can assume a normal distribution. And so some of these steps are going to be familiar to previous lectures. We're going to check that skewness statistic. And if it's not normal, if we can't assume that it's normal, then we're going to have to make some adjustments. Those are what we call transforms. So those are the first 2 pointers right here under step number 1. We're going to check our 2 variables. We're going to check it for skewness from the descriptive statistics, compare with our table. If we find it's non-normal, we'll do some transforms down here. But let's do this first part before we do anything else. And you've done this before. I'm going to start with the satisfaction variable. And I'm just going to go up to data. Data analysis, select my descriptive statistics, I'll click OK. I'll input my range, so that's going to be column B. I do have labels in that very first row. And I'm going to click my summary statistics box, and then I'm going to select a place to put the output. Here I'm just going to select cell G2. And we're going to need 2 things out of this output. We're going to need the skewness statistics. I'm just going to highlight that really quick. And we need to know our count, because we need those 2 things to look at that skewness table. So we know we have about 80 participants here, and our skewness statistic is negative 0.87. Now I'm going to point out here that we're going to assume that we have sample data. That way I don't have to adjust the standard deviation and the variance. But just remember that if you are assuming you have population data, or if you have population data, the standard deviation and the variance will need to be adjusted. We talked about the formula to do that for standard deviation. It was equal STDEVP, open parentheses, select your original data, close parentheses. I'm not going to go through that here because you've seen it in a previous lecture. You go back to the measures of central tendency and variability lecture in Excel. It'll walk you through how to do that in those situations. So we're going to continue from here. We're going to take a look at our skewness table. We have a count of about 80, a skewness statistic of negative 0.87. So looking at my skewness table here, I'm going to look at my count. So remember, N is the number of observations. We're going to round here. We're going to round to 80. And we see if we can assume a normal distribution, then that skewness statistic should fall between plus and minus 0.41. Here again, we have negative 0.87. That is going to be lower than our lower bound of our interval. So it appears that when it comes to satisfaction, it looks like we have a negative skew here. So we're definitely going to need to adjust and do a transform to try to make this variable closer to normal so that we can get more accurate z-scores when we get to that part of this module. As we've talked about in previous lectures, if we have a negative skew, we need to adjust our data by squaring or cubing or taking to the fourth power. Essentially, we want to take our original data and increase it to a power greater than 1. You're going to see that in this next part right here in the directions. We're going to create a new column for our transform, and we're going to use our formula equals, we'll click on a cell, we'll take it to the power greater than 1, and I'll show you how to do that. So we'll do this caret symbol, this up arrow symbol, and then we'll put in a value greater than 1. And then we're going to drag that formula down so that we replace all of our original data with the transformed data. In this case, a power greater than 1 could be a square. So we're going to start with a square first. If that doesn't work, then we'll go to a cube, and so on and so forth, so that we can address the skew in this data and make it fall within our range of what we might consider to be normal. Let's go back to our Excel spreadsheet. And so again, our directions are telling us to create a new variable. Now, it doesn't really matter what you name this variable as long as you know what it is. I like to go with T for transform, underscore, and then the original variable name. That way I know exactly what's going on there. This is the satisfaction variable, and I've transformed it to make it more normal or normalized. So I'm going to put in my formula here. I'm going to hit equals. So just like it says in our directions. And I'm going to click on the very first cell underneath the label for my variable, in this case for satisfaction. And here, because it's a negative skew, I want to stretch out the distribution, so I'm going to take it to a power greater than 1. In this case, we're going to take it to a power of 2, which would be squaring the data. So to do that, I'm going to hold down the Shift key, and I'm going to press 6 on my keyboard. That's going to give me that little caret or that arrow, that up arrow. And then I'm just going to type in a 2. So I'm going to take it to the second power, which is a square. I'll hit enter. And so if I've squared it, 4 should now become 16. 4 times 4 is 16. 5 times 5 would be 25. So let's drag down this formula, and let's get all the squared values for that original satisfaction variable. So I'm just going to drag it down, just like I've shown you in previous videos. We'll grab that lower right-hand corner, left click and hold, and I'm going to drag it until where the data stops, and that's where I'm going to stop as well. And I'll let go. And so that formula is going to drag down, and so it's squared all those original values. So if I'm looking in that satisfaction column, I'm going to see that my 5 became 25, my 7 is now 49, 3 is now 9, so on and so forth. It looks like our transformed worked. It's always a good idea just to kind of check a couple of them, spot check it, just make sure that the transform dragged down correctly. So there's our transformed variable. Now we want to check it. We want to make sure that this new variable is now going to fall within the normal range on our skewness table. So just like before, we'll go up to data analysis. We're going to get our descriptive statistics, except now I'm going to change that column from the B column to the D column where my transform is. Still going to have that labels in the first row box checked. Still summary statistics are going to remain checked. The only thing I'm going to change now is that output range. I'm just going to place it underneath my original variable output. I don't necessarily have to put it there. I can put it anywhere, but it just makes sense to me just to keep it in the same column so I can compare them. Click OK. Here's going to be my new output. You're going to notice that that skewness statistic is now closer to 0. So what we want to do is we want to check, does it fall within the range of what we would consider to be normal? So let's go back to our directions document. We have our table here. Again, our sample size is still 80. We want it to fall somewhere between plus and minus 0.41. And it looks like in this case, our skewness statistic of negative 0.39 just barely falls within that range. It's now what we would consider normal enough. So when I get my z-scores, I can be fairly confident those z-scores are going to be accurate in representing my original observations. So this variable is now good to go. Let's take a look at that other variable. So here we have alcohol. Now remember, we have some blank cells here. So we need to push those cells down to the bottom. To do that, remember, we're just going to highlight the column. We're going to go to our sort and filter button. And we're going to click either sort smallest to largest or largest to smallest. It doesn't matter. I like to do smallest to largest. make sure you expand your selection, and I'm going to click sort. Now notice when we did that, the rows stayed the same within our data, but the rows within our output did not change. That's because we have a couple columns between our data and the output. You always want to make sure you have a couple of blank columns in there. Otherwise, when you sort your variables, it's also going to sort your output. It's going to jumble it all up, and it's going to look terrible. So just make sure you have some columns between them. That's why I say put your output a few columns away from your data, give it some space. So now we can see that with our variable alcohol, we push those 2 blank cells down to the bottom. So let's get our descriptive statistics for alcohol. You know how to do it at this point. I don't need to necessarily walk you through it. We're just going to change that input range to column C and change our output to a different column in our data set. I'm going to put it in J2 here. Click OK. Then again, we're going to look at that skewness statistic. Here, our count's going to be 77. Remember, we had those 2 blank cells, so that's not going to be counted in our count here. Okay, our skewness statistic is rather large here. I can tell just by looking at it that we're going to have a positive skew. But let's take a look at the table just to make sure we're all on the same page. So again, 77 observations, that's going to round to 80. So I'm going to look at this 80 row right here. We want between plus or minus 0.41. Obviously here, 1.8 is way far outside this range, someplace way out over here in the positive direction. This is going to be a positive skew for our data. So with a positive skew, that means we have a tail in the positive direction on that number line. It's being extended to very large values. We want to bring that tail in. We're going to change that data by using a power less than 1. And again, you'll see that here in the directions. If we have a positive skew, we're going to take that original data and take it to a power less than 1. That would be like a square root or a cubed root or a fourth root. Obviously, we're going to start with a square root first. If our skew is too extreme, we'll move to a cube root and then a fourth root, so on and so forth when it comes to transforming the data. Let's go back to the Excel spreadsheet. We're going to create our new variable here again, just like before. We're going to be T for transform underscore alcohol. And remember, now we want to transform it to a power that is less than 1. So I'm going to select that very first value that's underneath the column. In this case, it's that first 0. I'll do the same thing as before. Shift 6 will give me that caret. And then now I'm going to put in a value that is less than 1. And here, if I want to do a square root, I'm going to put in 0.5. When it comes to root conversions, if I want to do a square root, then I will use the value of 0.5, just like we did. If I want to use a cubed root, that's a 3 by the way, we would use a value of 0.33. Essentially, this would be 1/3. 0.5 is 1/2. If I want to do a fourth root, I would type in 0.25. Essentially, that's 1/4. And so as we convert, depending on the root, all we're doing is taking the root, in this case the fourth root, and putting it under 1. And then we're just doing the math. 1/4 equals 0.25. 1/3 equals 0.33. So that's the value we're going to put in to Excel when we're doing our transform. If I want to do the 10th root, it'd be 1/10 or 0.1. Just keep those conversions in mind. In most cases, you won't need to go too much further than a square or a cubed root, but just realize depending on how skewed the data is, we may want to go a little bit further with our transform and do a fourth root or fifth root, or some cases a 10th root if it's really, really bad. All right, so here we're going to start with that square root. We'll put in a value of 0.5. We'll hit enter. And notice that 0 is going to stay 0. It's not going to change. But let's go ahead and drag this formula down. So left click, hold, drag. We're going to stop where the data stops. And so the square root of 100 is 10. And so when I let go, I should get 10 there, and I do. So it looks like my conversion looks accurate. Now notice here I stopped where the data stops. Had I continued, I would have got zeros. The problem with that is zeros are a value. And so if I get zeros in my data set, that's going to affect my mean, it's going to affect my standard deviation and my variance. And so I don't want to add values to my data set that were not originally there. Remember, these were missing data. We don't know how these people would have responded. So we want to make sure that those are not included. And that's why we push those blank cells down to the bottom, is so that we don't accidentally include them in our data. If we do include them in our data, then our measures of central tendency and measures of variability will be inaccurate, which means our z-scores will then be inaccurate. All right, so you see our 25s become 5, so it looks like it did what it was supposed to do. There's our transformed alcohol variable. Let's go ahead and let's get our descriptives and see, did this solve our skewness problem? Can we now assume that our variable has been normalized? Again, you know how to do this already. We're just going to change that input to column E now, and we'll change our output, and we're going to put it just right below our original variable output for those descriptive statistics. We'll click OK. And again, what we're looking for here is that skewness statistic. Looks like we're going to get 0.22. If I go back to my table, again, with 80 observations, we want something between plus or minus 0.41. 0.22 does fall within that range. So we can now assume that our transformed alcohol variable is normally distributed. So when we go to do z-scores, we'll use our transform data to get those z-scores, and we'll be reasonably confident that our z-scores will be accurate and will reflect our participants in relation to the overall population. Okay, so that's it for this video. Please remember to upload your spreadsheet with your name as the file name and submit it below.